Hello everyone. Today I gonna show you I gonna present you the topic of the low cost electronic hydrology monitoring. Yes, and in this topic is related to the this a float here, the float of control cell containers, laser grids, and monitoring river level for tropical environment supported by the ANR, Republic Française, IRD, Dean Boom. Here you have Alain Pierre, Norbert Silvera, Theodore Lasjak, Kamprasit Sanyavong, and Pavilai Sunyafong, Oliveira Vivosi. Here, for this specification, it can be used as to replace of SE 200 OTC SE 200 like a water level gauge in the stream like this one, and the piezometer, and also in automatic language with the Campbell and data logger. Here you can remain autonomously operational for several weeks. Remote control location. It can be operated in the harsh climatic condition of humid tropics. No need for external power source. No need for solar panels. Here you have a measurement principle. The principle is very simple. Here you have the stand method. You measurement the time light take to travel from the light source to the light sensor here. The light source here to the light sensor here is reflect here. Here you have a target, you have float. So for instance, we would like to know that the water level here equal D here plus H. H equal the height of the float emerging above the water surface here. D equal C multiplied by delta time divided by 2. Delta time is a time difference between pulse and emission and reception. Here you have electric design and wiring. There is one JRT distance meter. You have one TRC clock and two Arduino board MKR family. Here you have 30, or you have a micro SD card. Yeah, you have TRC clock with the coil cell battery switch and connect to the distance meter. Here you have electric assembly. This is overview of the electric assembly. As you can see here, the TRC clock with the cell coil cell battery here, the memory card, SD cards, micro SD cards, an overview of the solder ground and VCC pin of the TRC model under the MCAS MKR mem card here. And this is the control program structure. You have set up initialization initialization, LED pin, and so on. But you have a two operation mode. The main operation is to make measurement every minute and save data to the micro SD. The switch triggered operation mode is turned on the Bluetooth low energy the communication. You have two main loop here. You have mechanical design for the case module. Here you have a switch, the battery container, the Arduino board, and this transmitter here. Here you have a design for the mechanic design for the field setup for the water level monitoring in the VR. This is a cell container gas assembly. Here you have external strainer tube. Here you have a float guide tube with the float. Here you have the part of the module. As you can see here, the cap, the tube, the switch, the battery container. Here the Arduino card connector to the this stand metal here. Yeah, you have BFL communication and data download. You can use BFL communication to download data using the mobile phone or the tablet. Yeah, the device qualification compare between the manual and SE200 water level meter is very good for the correlation between laser gauge measurement and the manual SE200 measurement. The slope and linear correlation quite efficient. Both are very close to one, so it means it's almost the same. Yeah, you have the field deploy the cell contain water level gauge at the Entropic Critical Soul Observatory during the 2024. The comparison between the SE200 in the Cinco rain event and the laser unit. The black is a laser unit, laser. The curve, the red is SE200. As you can see, we start at the same point and end with the same point also. Here the field deployment of the cell control in the water level gauge in the entropic critical critical source observatory between 2024. Also, the mean absolute error is 22.6 millimeter over the measurement range of 0.5 meter. Here the perspective, the design chosen is versatile enough to apply to another applications like groundwater monitoring in the piezometer, the rainfall monitoring in totalizer in the rain gauge. So here we have still have a development to improve the power management, to implementation of very low power. This is we done already. There's still some TRC drip clock correction, drift correction, addition of the GPS module, minimal LoRa GSM telemetry as a mean to remotely access the status of device. Yeah, you have finished. I finished. Thank you for your attention. No, actually, am not talking about education. I talking about the uh, the low cost in the topic low cost electronics for hydrology monitoring. So that's you can have a look.